man. You ever look in the flatter?
Side it. Tides out a little ways. But I do got my camera down low, fairly low. And I will try to get it down lower if the tide continues to go out. Now I'm out in that area there where the light shines. You can see here.
I watched the other cars by one car, and then they still way out of it in seconds.
Focusing here.
Oh, he got yanked probably as soon as he hit the other one.
Alright, I think I posted some of this footage before in the past. I filmed this on 11/19, 2018, and at that time I did make a mistake on the misidentification of Hernando Beach bird rack compared to the Billy Steels. But this is approximately 6 miles away. Let's go 5.5 to 6 miles away. My camera height is at 43. Well, actually, just a tad bit over 43 inches. I got pictures at the end show my camera height. Plus two, from this angle, I was up a little bit higher. Obviously, you can see how this light is still reflecting off the water, causing light to diffract up and block out a portion of this boat. Now the thing is this these two little things off to the side of this rack are only about 5 feet tall. Okay, the cross member beam going from the bird rack to those two little other little posts there is only about 5 feet. Now you can confirm this by going back to my video where I went out to all these bird racks and got their coordinates. So anybody can check that out. I'm not out here to lie to myself or lie to anybody else. These are observations that I've made, and then to confirm, not only my camera height but the distance to them, I went out and got all their coordinates. Now, what I do need to do, because I did have Buster Brown did a little video where he marked all these bird racks, and the only one he didn't put on there was the Bayport bird rack, but pretty much know that that's about, the Bayport bird rack is about 3.5 miles from Pine Island. Could be a little bit more, being that that was based on the Hernando or Bayport distance. But obviously you can see these, see how this light is reflecting off. Now, if I go by, my visibility limit on this particular day, my visibility must have been 6 to 6.5, maybe 7 miles. And anything after that point is being mirrored. That water is being is mirroring, and it is just mirroring the sky above it. And this is how we get our backdrop. Now sometimes that mirroring is really heavy, and when it's heavy, I do believe too we have a lot of lensing, I want to say. People call it atmospheric lensing. Well, we know that what the word atmosphere means, but let's get the sphere out of there. Make it atmosplane, whatever you want. But you know, when I'm looking at all these videos that I've done and my observations, I watch this boat and its little wake go by. Whoop, blocks everything out. Um, So again, you know, waves do block out boats. So not only do we have the light diffraction, we also can see obviously these waves flickering up and blocking out the bottom portion of that boat. Now people want to know why bottoms of the boats, the hulls disappear. Well, this is just one proof that this is part of it, but there's other optical effects that occur when we have that mirroring effect occurring. I can watch this whole bird rack get cut off well over halfway up it, depending on different times. Even if I go up higher, I've got video of this bird rack from on top of this little observation deck that's behind me, that it's cut off, still cut off. Why? Because my visibility limit was a lot less at that day, plus adding in the mirroring effect. It cuts everything off. So when they say light refraction is pulling things up above this supposed curvature, it's not. It's actually getting lens magnified and pulled in. Anything beyond the visible water gets pulled in and down. And this is why things appear to be chopped off, because again, I've gotten footage where I've had my camera at 28 inches and was able to see boats going way, way out, you know, 8 to 10 miles out, and you could see them perfectly still in the water. So, you know, somebody's going to tell me that light refraction is pulling all of this cut off water up from behind a curve. It's just absolutely nonsense. I really can't understand how they've gotten away with this for so long. There's these optical effects that occur that create these illusions of a curve. It is an illusion. And that's the same thing. That's why the sun always appears to set. And also perspective is going to make something set. But trying to focus in on a light source that they claim is 93 million miles away is also an issue, because I believe through all of the, you know, hundreds if not thousands of miles that the sun is penetrating through our atmosphere, our weather conditions, it magnifies it, and it continues to magnify it as it gets farther and farther away. Now, I got a little audio coming up on my next clip of cell phone footage, so check this out.
Okay, there's where my tripod was at. I was filming a little earlier, and I brought my other tripod down here, put it right in the water, and let me put my camera right next to this camera and show you. That was up much higher. And, there's the bird rack still in there. See? And there is a boat to the right. I lowered my perspective and still was able to see it. And I'm out there in the hot spot, just as I just showed a second ago, and you can't see shit out there. And even if I zoom this camera in 8 times, you still can't see nothing. That's 8 times zoom on a cell phone camera. Of course, I don't have a very good focus on it when you're zoomed out that far, but you can.
Okay, so sharpening my angle right here in this little part, I'm just trying to focus in on the water, that visible water line, and you know, that's the thing. my angle is anything beyond this water. I cannot resolve it. It's just too sharp of an angle. So again, I think our visibility limits, of each and every day, which our visibility limits change from day to day. I mean, even from hour to hour or minute to minute. I've actually been out filming and watched it go from mirroring to great visibility back to mirroring again. And it's really weird. Now, here too, look at this other boat off to the right of this. You can see it right there. It's even getting blocked more because it's a little farther away from this boat. But look how much that light diffraction blocks off now. Now, if you really look, you can actually see that I didn't really cut much off. Just by lowering my camera, I created more light diffraction. So it's just sharpening that angle creates more of a light diffraction. Now, I am in the hot spot of the sun. So the hot spot is right there in front of me, and you'll notice here shortly I'll zoom back and I'll show that this bird rack is right in the hot spot. But light diffraction is still occurring, and this is why too I'm always talking about the angle of light where the sun is in reference to where I'm pointing my camera to. Or where it's at, it creates other issues. Like I've been out filming and filmed the boat coming in, getting closer, closer, closer. He comes out of this this mirror zone or compression zone, ether band zone, whatever you want to call it. It comes out of it. You can see it perfectly in the water as it got bigger, and then as it got around the Hernando Beach area, right around I think it's this particular bird rack, all of a sudden you could notice it sinking into the mirroring effect. I mean, and then it gets chopped off, cut off, and people don't look at this. They don't really study these observations and pick out these details that really show truth. Again, you can still see this cross member going across the water, or from the bird rack to those two posts. Again, it's only 5 feet tall, approximately, and that would depend on also the water, the tides. The higher the tide, that space decreases. The lower the tide, it increases. So tides are also playing a role when I'm out filming. Long periods of time. I could be out there filming and the tide's coming in or the tide's going out. And the best time to really film is during a dead tide. A dead tide is when the water is still. And not just still from moving, but also still from no wind. A lot of times I get really, really great visibility during those times. Other times I've gotten great visibility when there was heavy winds. But really, really good visibility. I do believe it was in July 21st, 2018. I put out some footage. Yeah, my camera was up. It's like 5-6 feet off the water, maybe even a little more. Wasn't really paying attention to the height of the water on the seawall on that particular day, but I could always go back and look. But on that particular day, I had really good visibility. Why? I think even though I had the wind blowing, I was able to have the water and the air temperature approximately the same, so it was giving me good visibility. So there's all these factors that occur, or these different effects that will affect our vision, our viewing zone, our viewing area. And then again, you sharpen those angles, and the more you sharpen them, the more light diffraction and or mirroring effect you get. Now this boat is obviously behind that bird rack. It's not in front, it's behind. And I have more footage that went with this, but I was trying to keep this video a little bit short. Yes, it's a little bit over the the length that I wanted it to go. But what I did was I added in some pictures of my camera, a height. Also, I put in a picture of off of Google cartoon Earth, and then I put in some metabunk refraction chart where you could see my camera height, what was supposed to be cut off, and what's not supposed to be cut off. And again, it fails miserably. Mick West's curve calculator is there's too many variables, if you ask me, to put math to it, because you have all of these different effects that are occurring all at the same time, or in combinations, or just one, or two, or three, or four, or five. I mean, there's many different variables of these effects. From mirroring to this light diffraction, angle of the light. You could also have poor visibility that particular day. You got the lensing effect that's occurring. All of these things are affecting what we see. And when you start really paying attention to all these details, things start falling in place to where you've been lied to. Maybe the people that are lying to you really believe what they believe, though. And this is the issue that I think is occurring, is they really believe that, these numbers are all correct and that you can do this, put a geometry on it and figure out the curvature and blah, blah, blah. But I really suspect that they believe it. And that's why they push it so hard. Same way with the globe people. They, seen a picture of Earth from space or a video of Earth from space. So immediately, if it's on TV or if it's written in a book, it's got to be true, right? I've read it, so it's got to be true. All right, here's my camera height for that particular day. A little less than 42 or 43 inches, but I'm going to call it 43 inches. Actually, in Metabunk, it's going to come up a little bit more than 43 inches. And then here's my location. The Hernando Beach Rack is 6.29 miles. I'm actually calling it 5 to 6 miles. A little discrepancy there. Just to kind of, because I'm not sure on if these measurements are exact, but they're close. They're real close. All right, so for 5.5 feet, there should be 5.11 feet missing, or hidden should be 6.73, blah, blah, blah. But we know that from that cross member beam, that's bullshit. Otherwise, I wouldn't be able to see it. And then here's another one, 9 feet. So that bird rack should be cut off big time. Yeah, it fits the mirroring. Their math fits the mirroring and some of the other effects, but it doesn't fit reality. Thanks for watching.